Alright, we're back. More crappy tripod shooting. Somebody keeps saying they want to see tripod shots. I don't know why I hate them. Alright, so here is the head we're putting together. We're going to be using the Manley spring kit here, which is a conical spring kit. So it's lightweight. So basically you're going from this package here is a new one, this is the old one. These are a lot heavier than this. Gives you more weight on your valve train. So the difference is your parts here. Okay, you got this big collar and these big heavy keepers here. You got two of them versus these little lightweight keepers and this little small top collar. So big difference of weight between this package and this package. So that means for lighter valve spring tension, you get more RPM. Lighter tension means you have less wear and tear on your valve train, less lifter problem, less rocker problem, valve guide issues, all that negative stuff. The disadvantage of this spring is it does not build very much pressure up. So on a big cam with a lot of lift and a lot of duration, quickly accelerating ramps, so more toward racing cam, not street cam, it can overcome the spring tension real quick and get a floating problem. So you got to be careful. These springs are pretty good because they give you dimensions right here on the inside, what you got for dimensions. So they want us to put it in at 1/800 installed height, and the coil binds at 1/200, so that's 600 lift. And they're saying that full coil binds at 0.85, which is a lot less than that. And that puts out 150 pounds at the 1/800, and it's 355 at 1/200. So I measured these, and we were actually getting more like 155, 158 at the 1/800, and we were a little bit less than this on the open, but close to it. So it's close. We're going to be running a crane cabinet, which puts out 619 lift with a 1:6.5 ratio rocker, which they don't make. 1:6.25 is normal ratio, which means it only lifts 610, not 620. And we had to figure out calculate up our TD overlap lift. So they give you what the cam is, you multiply it by your rocker ratio, and that gives you the actual lift at the valve. So the valve clearance, the valve lift is important because you want to make sure the valves, when they come up, they don't hit each other. So I checked these two, and we're going to have about 40-50 thou clearance between them, basically like that, when we're installed. Now the way you do that measurement is you put them in the head. You come over here, you measure how far it is. You go in a couple hundred thou on that one, a couple hundred thou on that one, and then you flip the head around without tilting it, and you look at what your clearance is on the other side. So ideally you want to have 50-60 thou clearance. The closer it is, the closer you are to blowing it up. So this motor here is a stock valves. These heads only had about 5,000 miles on them. So I went ahead and honed the surface so you can see the uneven wear marks in there. I butted the tips so I cleaned them up and reground the valves with multiple angle. So I got the seats already lapped in so you can see the seat, and then the seat cut angle is only right here, and this angle over here is a back cut angle, and then you flow into your tulip angle. So that eliminates a little bit of a sharp edge when you do it like that. And this is the valve here, so you can see how it's smooth flow all the way across. Now the heads, we actually ported these out, so didn't do a lot of cutting, but we cut it in the correct spots. So basically intake manifold is stock because it's a fuel injection system, so we got a stock fuel injector, so it's relatively small. Basically I just kind of cleaned up all your radiuses and took out the waviness that was in there, and the area where it was kind of plugged up was hard to see in here, but my scale out here, right through about right in this area here is where I did grinding, and to make it where it's a nice even radius all the way through here. It had kind of a flat spot in there. There's kind of a hole right in this spot here where my scale is. Maybe from this angle you can see it, I'm not sure. It's hard to show stuff in the camera. But anyway, right where my scale is down in here, which is lost view of it there, so There we go, right in that area down in there. There's actually a hole like right there where it'd be better if it was filled in, but can't fill something in that's already cut. In this case casted, so we left it. So all we do is we just smooth it out as best we can so you get a nice smooth flow all the way through. So you want to make sure you go around the valve guide fairly equally. Trying to get it where you can see it. So going around both sides here, you want to make sure it flows fairly equal on both sides from both directions. So this side here, you can see how you go around the valve guide there, and it's pretty equal hole size all the way through on both sides of the port here. So you want to take full advantage of your valve head. The exhaust, same thing. You can see the black stuff is original carbon. I didn't cut. And same deal. I opened up the valve guide in that area where it was tight. Smoothed up the radiuses. You can see how there's a lot more grinding on this side of the port here, which is right in this side here. It's really hard to hold that where you can see without holding the camera. And the other side, it's over here. I didn't do a lot of grinding through here. A little bit, but not a lot. Did more on the other side. Same deal, you want to equalize the flow so you get better flow. I'm pretty well getting tired of this tripod already. I can't move the camera how I need to look to show you stuff, so we'll pull it off the stand to get a better idea. See how much better a job I can do now? So you can see how it flows really nice around both sides. Hi Joe, you're back. So anyway, you can see how the port flows nice and evenly all the way around now. The exhaust, same thing, flows all the way around equally around the sides. Some of that had to be cut out, like I said. So that's all you're looking for. You're not really making it bigger, we're just making it straighter. And you also see how the head gasket's nice and clean now after we clean all the goop off. So these went through 2 more cleaning cycles after I sanded them. So I think we cleaned these heads, what, about 14 times now each?
Seems like it.
Yeah, it has been. So anyway, this is the other head, same deal. Nice and clean on both sides. Let's go grab me the injector over there. So this one here I had to take a stud out that was all screwed up. So we had to heat the head up probably 1,000 degrees here before the stud would come out. Luckily it came out. Here's the injector. So this is whatever stock size is for a Screaming Eagle bike. So this one here, I went there and smoothed up everything, radiused everything off. Did quite a bit of grinding right through here. It was just a machine sharp edge there. Blended it all here. Also blended it way down inside and the radius way up in here. Knocked down the bolt boss right here. That's the boss right here for the bolt. So I knocked about half of that off. So now it flows across the top pretty evenly. Got that done. There was another hump that was down in this area, way down and deep. You can't see, but I knocked it out too. And there's also a big hump probably for this thing over here. Yeah, that one there. So the inner one, not the first one, the one way down in there in the middle. I ground that down a little bit, radiused it really nice so it's not a sharp edge in there anymore. So anyway, you spend about an hour in there dicking around with that stuff. You're not really looking like you're doing that much, but all of those humps and stuff that are in the way make a difference. It all adds up to being bad flow. So if you make it flow nice and straight, even if the quantity of flow doesn't increase, the quality should, and quality is always better than quantity. So, alright, so right now we're getting ready to, we already checked all our valve spring heights and everything. I'll run that through real quick and show you. See how to do it. We're showing what we did yesterday for 4 hours, 5 hours, whatever that was.
I think it said it was 10:30 when we left. It was 1:30 when I got home, or 1 o'clock when I got home. I thought you said it was 10:30 or something like that.
It was 10:30 we went up front. It was after 12:30 before we left.
Yeah.
I didn't get home until after 1 either. It was a long night.
Definitely.
Well, not long for me. That's about normal for me.
Yeah.
Anyway, all right, for checking our install height, the first thing we do, we had to do a coil bind to see what the coil bind really was, so we can put it in a vise, washed it, and you measure between your collars. So you got your lower collar, your upper collar, you squeeze it flat and you measure it. So instead of being 108.5, I was getting 125 and 150, so a little bit off. You want at least 50 thou clearance from coil bind. So that means we got to be 1/200 is our lowest number we can run, which happens to be the number they had on the box when they give us a check, but we don't have that extra clearance like it says here. It wasn't there. So what we're going to have to do, we're going to run 610, 620 lift, so we're going to have to run this at more than 1/800 installed height. We're going to be at 1/810 to 120. I went for 120, just in case the rock runs give more than they're supposed to, which rarely ever happens, but you always want to make sure you got a little extra clearances. So this is an installed checker here. You unscrew this here with the collars in there, and it has measurements, tells you what you got. You're not messing up all the valve there, are you?
I'm not doing anything.
You're not doing that?
I'm not doing anything right now. We got them all set up.
Oh, we also cut the seats here in the head in multiple angles and radiuses in here with my valve cutter.
And the valves.
I already showed the valves.
Oh.
So the seats we didn't show, we did on the seats. But
Oh.
they have multiple angles and radiuses. You wanted a 3-angle valve job, we got at least 3 and probably 2 or 3 radiuses on top. Okay, so you put the valve in there.
Hear that nice solid sound it makes?
Yeah, it looks good. And it's light tight. That means when you look through here,
See no light.
you don't see no light coming past the seat up in here.
Light tight.
Yeah, that's we learned that. I learned that from Total Seal. Light tight. I just call it, if I don't see any light, it's good, but they have a fancy name for it. Okay, we got to put our install heights we want to be. I got to run 2 thick shims, which are 60 each, and a thin one, which is 15. You'll have to add that up in your head.
75, right?
Maybe.
On a good day?
On a bad day, it might be 65. On a really shitty day, it might be 85. Okay, so you put your lower collar, your shims, your upper collar, and your keepers. See, this is your job. You do. You hold the camera.
Mm-hmm. It's holding it just fine right now.
I was getting complaints about somebody being too close
Oh, really?
and moving the camera too much. So now they want a crappy tripod shot. So we're going to give them a crappy tripod shot. Now, if you like the crappy tripod shot, let me know, because I don't like them. Okay, you tighten up the install height checker, and you can see the number there is at 825 now, maybe.
Yep. Right on the dot.
Yeah, you can see it, but see the camera can't see.
No? Bad angle?
I don't know. It's hard to do.
Bad light?
When you're in front of the camera, it's hard to hold it where you're seeing. That's why I don't like tripods. I can move the camera.
Right.
All right, so we already did all this checking on all of these. You notice how the keeper's digging really nice and tight? That's a good sign. Tight keepers means I'm happy. Loose ones, I'm not happy.
Don't mix up the parts either.
No, once you have this installed height done, you want to make sure that every piece that you check goes in the same pile. So they all go over here in the same pile. Now I always put my valves in the same way when I line them up. So we have front and rear head. Each of the rear head goes on the left, the front on the right. And that means the exhaust over here is your rear end exhaust, rear intake, and front exhaust. Kind of like it is in the bike. And you line up all your parts that way. Now the springs we haven't put in the right spot yet because they're all the same more or less. Sometimes when I get really close on clearances, like on my race bike, I actually measure every spring, and a lot of times I go in and I'll grind it flat here and get more room. They don't tell you you're supposed to do that in the comic books, but when you need clearance, you need clearance. Okay, this takes Ironhead Sportster intake seals on this CVO 110 twin cam bike. So if you want a seal for this bike, it is an Ironhead Sportster intake seal.
They look good, huh?
Yep. Now this is the racing style ones, which have the spring-loaded Viton tip instead of the old Clad Show ones. These will not work on an Ironhead; they're too tall.
Really?
Yeah, you have to use the other style seal. This is a steel clad seal. It has no spring-loaded lip, but look how short it is. This one has a spring-loaded lip. Look how tall it is. So when you put these side by side, there's a big difference in height. An Ironhead has no clearance. Evos and twin cams have lots of clearance. We'll see how much a lot is though right now. we didn't check that last night. Okay, so check our clearances for our valve seals. First thing you gotta do, you gotta measure how deep your seal is this way, so you know how deep it goes on, and then you know how much is on the top. So this one here is roughly about 330 on the depth. The overall height is about 530. So what's the difference?
200.
200 thou sticks above the guide. So that means you got to make sure you got 200 thou plus 50 plus your valve lift. So that's 620, 50, and how much? 200. What's that add up to?
620, 670, 200,
870.
870.
You want to make sure the intake valve goes in the intake hole. Then you got to take your collar and your keeper, assemble them. And you pull them up and you measure the distance right there. And I have no idea if they can see that in the camera because I'm not looking at that. Here, you watch the camera. Can you see that?
Mm-hmm.
Okay, now you want to make sure you got how much number we wanted?
970?
870.
870?
We have about 980.
So the shims will make up for that?
So that means we have lots of extra clearance.
That way we have the shims in there though?
I'm not measuring the shim, I'm measuring the valve guide to retainer.
Oh, okay.
The retainer, when you install it, was down in here. So
Yeah. So we got plenty then, huh?
the next dimension you want to check is you put your stack of shims in there in your lower collar. And then you measure here and you see if you got 300. And 330, I think is what I came up with. In this case here, we have 280.
What are you measuring to? From the top of the stack?
Top of the collar to the top of the guide.
Oh, okay.
Can you see that in the camera?
I can see it now, yeah.
Okay.
I wasn't sure where you were going.
So right now we are going to be short about 40 thou. So that means when this goes on, it will not be all the way against the top of that guide. It's going to stick up higher. So that means you have to add that to the other number. So we have to take the 870 and add the extra 40 to it. So now you're about 930. Luckily we're still going to be about 980, so we still have clearance. Now if we needed more clearance, we would take the, we can't change the valve stack because we need that in there, the shim stack. You can actually take this collar and you can cut it away. Some of this away to gain seal clearance here.
Okay.
You can also bore this out and put the seal inside of it, but I don't like that because that has a well of oil that it sits in and it sucks the oil up. And it sucks oil past your seal a lot of times. So. These seals here do not have a rubber on the inside where it goes on the guide. So it can suck up between the two surfaces. That's one reason why I put Loctite on there, to help seal up that area, also to hold it on so it doesn't fall off. So you're doing two things at once, as usual.
So they go on there before the springs and all that, huh?
Yeah.
Uh-oh. Don't mix them up?
I didn't mix them, I just slid them over there, get them, they're friendly, it goes in the
You're
same
still
head,
good. All right.
so they're just getting friendly with each other. It's like brother and sister, they weren't together. Alright, so now we have all our dimensions figured out and it looks like it's all going to work. Hopefully. We can go ahead and assemble something. So next thing we got to have a thing for putting this in. So are we even near where I'm filming right now?
Yeah, we're pretty good.
Okay, so we're going to, I have to have a driver to install this, so I could go and get a driver. That's not a Uber driver either.
And these little...
So these are drivers here for driving your seals in. So you want to have one that works correctly. Now this one here pushes on it, but see it pushes against the top of the rubber seal, which is not where you want to be pushing. So that one does not work. This one here you see have a bigger hole in it. So it pops in there, and the seal goes inside the cutout, and that should drive this one on. And the reason this is all red, it's because somebody accidentally opened up the ID of the hole so it would clear the seal. And I don't know who to do that around here, but somebody screwed that piece up.
That's a special tool.
Yes. See, this one is not a special one because see, it's not covered in red.
It won't work. It will.
So if you look at the ID, they are slightly different.
Mm-hmm.
So there you go, more specialty junk.
Can you show them the trick socket we made for the compression release?
No, that's top secret. You cannot look at that.
Yeah.
At least unless until we put the compression releases in. Okay, here's those junk cans we're not using right now. Okay, where's my compressor at? Alright, so we need some tools. We need that. We need a hammer.
Persuader.
And we need a screwdriver. I like my black one. Alright, so we're going to take a break. We'll be back in a minute.